Alright, y'all, so we're going to start our Diffie-Q unit, differential equations, also known as, we could write Diffie-Q. Oftentimes I'm not going to say differential equations, I'm going to say Diffie-Q instead, just because it saves some time. What I would like for y'all to do in this video is take notes along the way, and then we're going to have some time for you to practice problems. You'll pause, do a practice, see if you can do these problems on your own, but definitely take notes in your notebook. You can pause anytime if you need to see the screen for longer than what I have it up for. Make sure that you get these notes down. This is going to be on the AP exam. It's a very important topic, and we need to make sure that we have a deep understanding of it. So let's get started. First, we're going to start with what is a differential equation. Before we write down a formal definition, or really an informal definition, we're going to write some examples and some non-examples. So first, here's some examples of differential equations. dy dx, or the derivative of y with respect to x, equals 3x. That's an example of a Diffie-Q. That should look familiar. You've seen things like this. dy dx equals 2x squared plus y. Also an example of a differential equation. D squared y dx squared. This is the second derivative of y with respect to x. Second derivative of y with respect to x equals 2x plus 3 dy dx. Also an example of a differential equation. Alright, now let's do some non-examples. These are not examples of Diffie-Qs. Y equals 3x. That's not a differential equation. Sine of 3x equals cosine of x. This is not a differential equation. Y equals 3x cubed plus 6x squared plus 4. Also not a differential equation. Okay, so now let's kind of get an informal definition of what even is a differential equation. A differential equation is an equation that involves some sort of derivative. A differential equation is an equation that involves some sort of derivative. Okay, so if you look at our examples over here, all these examples involve derivatives. We had dy dx, second derivative, d squared y dx squared, dy dx. It can involve both the second derivative and the first derivative. A Diffie-Q can have any kind of derivative, and it will be a differential equation, an equation with any kind of derivative. Okay, now let's talk about the solution. This is going to be a key word, solution to a differential equation. The solution to Diffie-Q is always going to be a function. A function. So, you will see in a second that the solutions end up being functions, and then we need to put a little asterisk here, a star here. A single Diffie-Q, or a single differential equation, can have multiple solutions. So, this is a little different than what we're used to. A lot of equations that we're used to, when we solve them, we get one solution, like x equals something, or y equals something, and that's true for eternity. That equation has one solution. Differential equations can have multiple solutions. So let's do an example, and we can kind of see what the solution looks like. So we can check if this equation is a solution. We're trying to see, is this a solution to the differential equation, and we have this Diffie-Q, d squared y plus 2 dy dx plus 3y, or equals 3y, sorry. So we're trying to figure out, is this a solution? The way that we're going to do this, let's make a little note. How are we going to do this? Let's put a star here. This is how you do it. We need to find things to plug into the differential equation. That sounds kind of weird. Well, let me show you what I mean. Okay, so we can actually find some things to plug into this differential equation. We have this differential equation right here. Can we first of all start with y? Is y given? Yes. Y is the solution that we're testing, or we're like trying to check, is this a solution? So one thing that we can plug in to the diff EQ is this y. That is the same as this y. So I'm going to write over here, these are things that we can plug in. Y equals e to the negative 3x. Alright, what else can we plug in? Can we find dy dx? Can we find the derivative of y? The derivative of this y? Yes, we can. Dy dx equals negative 3e to the negative 3x. That's just the derivative of this, dy dx. Okay, and then there's one more thing that we can find. We can find d squared y dx, the second derivative. So let's go ahead and find that. D squared y dx squared, that means the second derivative of y with respect to x equals, we're going to take the derivative of this now. We have positive 9e to the negative 3x. Okay, cool. So now we found three things that we can actually plug into this diff EQ. Now, this is how, actually, let's just go ahead and plug them in, and then I'm going to tell you, like, how do we know if this is actually a solution. So let's plug them in. So we are going to plug into our original differential equation right here, d squared y dx squared. D squared y dx squared was this. So we have 9e to the negative 3x, let's see, plus 2, and then dy dx was this negative 3. So we'll say 2 times negative 3 e to the negative 3x, and then we have equals 3, and I'm looking back here at the original differential equation, but y is the same as e to the negative 3x, so e to the negative 3x. Okay, cool. So now that we've plugged everything in, let's go ahead and simplify. So we have 9e to the negative 3x plus, actually 2 times negative 3 is negative 6, so we have minus 6 e to the negative 3x equals 3 e to the negative 3x. Okay, so now that we've plugged in, let's simplify all the way. So simplify 9 minus 6 is 3. So 3e to the negative 3x equals 3e to the negative 3x. Okay, this is where we're going to write like our asterisk to finish this problem, or a little star. If after plugging in, you get a true statement, then y is a solution. Okay, let's check. Is this true? 3 e to the negative 3x equals 3 e to the negative 3x. This is true. So we would say, so this original y that we had, y equals e to the negative 3x, is a solution. We could abbreviate solution to this differential equation. So we could like finish this sentence by saying y equals e to the negative 3x is a solution to, and then write this, diff EQ. Okay, so now I want you to do a practice, so let me scoot this up. You are going to do this practice problem, and then I will help you check it by doing it for you in a second. So go ahead, work on this practice. It shouldn't take you longer than like 2 minutes. And if you're watching on YouTube, pause the video, do the practice, and then I'll go over it. So now let's go over this practice. We're going to do it the same way as before. So check if the equation y equals e to the x is a solution to the same differential equation above. That's this diffie q, sorry. Okay, so the first thing that we're going to do is find things that we can plug in. We have y, So y equals, I'm just making notes to myself, y equals e to the x. We have the derivative of y, that's right here. So we're going to say dy dx equals, derivative of e to the x is just e to the x. We also have the second derivative of y. So let's take that. d squared y dx squared equals derivative of e to the x, which is e to the x again. Alright, cool. So now we can take all of these things and plug in. So we're going to plug into our original diffie q. The first thing that shows up is the second derivative. We got e to the x, so let's plug in e to the x. The next thing that we have is plus 2, and then times this derivative, the derivative of y, which is also e to the x, and then we have equals 3 times y. This y was e to the x. Alright, next step, simplify. So now we can fully simplify this. We have e to the x plus 2e to the x equals 3e to the x. E to the x plus 2e to the x, that's 3e to the x equals 3e to the x. Did we get a true statement? This is true. And then we would say, so, finish it off. So, what was the solution that we were testing? Y equals e to the x. Y equals e to the x is a solution to, is a solution to, and then I'm going to write the differential equation. D squared y dx squared plus 2 dy dx equals 3y. Okay, cool. Alright, so you can see like we got two different solutions. This was a solution, this was a solution to the same diffie q. We could potentially have infinite solutions to the same diffie q. Alright, so now let's move on to solving differential equations. So, one of the biggest things that the AP exam will ask you to do is solve a differential equation. Another way that they would say this, like another way to say solve the differential equation, is find the particular solution. If you see those words, that is like a big key word saying that we're about to do like this method for a diffie q. So, this is just saying like on the AP exam they like to ask you to find the particular solution. Since we are pros at calculus now, this shouldn't be that hard. One type of diffie q that they are highly likely to give you is a separable differential equation. We'll talk about why it's called separable in a second. So separable diffie q's can be solved with this method. This is on your reference sheet, so I would study this from your reference sheet as well and make sure you know where it is. But let's go ahead and jump into this example. So go ahead and make sure you write these titles and then you have this example written down. If you need to, you can pause the video so that you can write the full example in your notes. Okay, solving separable diffie q's, step by step. You can always follow this process to solve separable diffie q's. So this is what the AP exam question will look like. It'll start like, given this equation, in the initial condition, y of 1 equals negative 1/2, find the particular solution or solve the differential equation. Okay, so y'all, sometimes it might not say differential equation, and you have to know that it's a diffie q, and you have to know, like recognize it, and then use this method. So how do we know this is a diffie q? Let's go back to like what makes a diffie q. It just means that there's a derivative involved. So like, yes, we have dy dx, we have it equaling something. This is a differential equation. Okay, first step, separate. So the first step is called separate. We're going to have to separate this differential equation. And get all the x terms on one side of the equal sign and all the y terms on the other side of the equal sign. This is called separable diffie-q, because you can separate it. You can get all the x's on one side and all the y's on the other. So that's what we're going to do. I'm going to color code my x's and y's for you. So I'm going to put y's in blue. So I'm going to rewrite the equation. We have dy, and then let me get like a black for just the other parts. dy dx, so like I'm just writing this equation, but having it in different colors so you can see the x's and y's, equals, and then we have 4x cubed. I'm going to put the 4 with the x, so 4x cubed, and then y squared. Cool. So we want all the x's on one side, all the y's on one side. The first thing I'm going to do, always, like when you're doing separable differential equations, when you separate, I would always start by multiplying this dx on both sides. So I'll show you what I mean. Times dx, cross out the dx's on one side, right? And then you have a dx on the other side still left. So let's rewrite what we have. dy equals, and then we have this stuff, 4x cubed times y squared times dx. Okay, we're trying to get all the x terms on one side and all the y's on the other. So we still have this y squared. Let's get that to the left side. And the way that you're going to do that is divide by y squared on both sides. Cross those out. Okay, and then we're going to go over here. We have dy over y squared equals 4x cubed times dx. Sweet. So you can see we got all the y's on one side, all the x's on the other. Now, we're about to integrate. The second step is integrate. So here's what I always want you to do. After you separate, I want you to get the dy, put it out in front. It's not a big deal. Like, it's going to make the integration piece look a little easier. So what I mean is, this dy over y squared can be written as 1 over y squared dy, right? That's the same thing. I'm not doing anything too fancy. Equals 4x cubed dx. Okay, I want you to always do this after you separate. So now we've finished with step 1. Let's go to step 2. So now it says integrate both sides. I'm going to take this and copy it over here. So I have 1 over y squared dy equals 4x cubed dx. Sweet. And now I'm going to integrate both sides. So let's just draw. I'm going to do my integral in green. Try to draw the integral on both pieces. And then we need to remember that this can be written as y to the negative 2. So if you want, I'm just going to do that here. So if you want, you could write, this is the same as y to the negative 2 dy equals the integral of 4x cubed dx, right? Now let's like actually integrate it. So the integral of y to the negative 2 is y to the negative 1 over negative 1. You would have a plus c. You would have a plus c, but I guess I'll show it and then I'll explain like why we're not going to put a plus c on the y side. But we're normally not going to put this on the y side. We'll only put it on the x side. The integral of 4x cubed is x to the 4th plus c. Okay, so here's what I'm talking about. We have 2 plus c's, right? I don't want 2 plus c's. I only want 1. So I'm going to subtract c on both sides. This c cancels out. C minus c, okay, that's a constant minus a constant. I don't know what the constant is, so that's just a constant. This turns into c. That just stays like a c. So the c on this side stays. I'm going to rearrange this to make it look more like what it should look like. So we have, this is the same as negative 1 over y to the 1, right? This c we got rid of equals x to the 4th. A constant minus a constant is still a constant. We're going to put plus c, plus some constant. Okay, cool. We've integrated. Check. Next step, isolate y. Actually, and you know what? I'm going to like box, like when you're done with each step. So we finished step 1 here. We finished integrating here. Okay, step 3. And y'all, these problems on the AP exam, you can get so many points if you do these problems right, if you do all these steps. So that's why I've broken it into so many steps. Alright, here we go. Step 3, isolate y. So we need to get this y alone. So what we're going to do is I'm going to multiply this y to this side. Here, let me rewrite the whole thing. Negative 1 over y equals x to the 4th plus c. Alright, multiply y on both sides, times y, times, you have to put this in parentheses, times y. These cancel. Negative 1 equals x to the 4th plus c times y. Okay, isolate y. We gotta get this alone. So I'm going to divide by x to the 4th plus c, divide by x to the 4th plus c. These cancel, and we get negative 1 over x to the 4th plus c equals y. Alright, sweet. So that is step 3. We isolated y. Now let's move to step 4, and we're almost done. Hopefully you've written down the problem at this point, because I'm zooming, or like scrolling. Okay. Step 4. Plug in the initial condition. We need to plug in the initial condition, and we're trying to find c. What is the c value? So let's go back up to the problem. It will tell you the initial condition, or it'll give you a point that it wants you to solve the diffie-q at. So this is the initial condition. The initial condition, y of 1 equals negative 1/2. Remember, this is a point. Like, this is like a hidden point. X is 1, and y is negative 1/2. So let's write that down here. We have the point. I'm going to write it right here. We have the point 1, negative 1/2. So we need to plug that in to our equation. So I'm going to plug in, we have negative 1 over, x is 1, so we have 1 to the 4th plus c equals, and then y is negative 1/2, negative 1/2. Now we have to find c. It says find c. So let's find c. I'm going to multiply this whole thing out of the denominator, because I got to get c out of the denominator. So 1 to the 4th is just 1, right? 1 plus c times 1 plus c. And you get negative 1 equals negative 1/2 times 1 plus c. I'm going to multiply times negative 2 times negative 2 to cancel out this guy. So we get negative 2 times negative 1, that is positive 2, equals 1 plus c. So I'm just doing algebra. If you don't like the order that I'm going in, you do you. Do whatever order works. I know y'all rock at algebra. Okay, and then last step, minus 1, 1 equals c. Okay, sweet. We have finished the last step, or we've finished step 4, sorry, and we're ready to move on to the final step, which is the fastest one. So we have 1 equals c. It says for the last step, plug in c to write the particular solution. So now we're going to like finish this problem up. The particular solution to the diffie-q. A particular solution or a solution to a diffie-q should always look like y equals whatever your solution is. So we're going to start our solution with y equals, and then all you do is you combine this, what y equals, but you combine it with this. Plug in your c. So c is 1. So now we have negative 1, I'm looking over here, over x to the 4th, but c is 1, right? So plus 1. Boom, done. So what is this thing? This equation is going to be the line that passes through the point, the given point, 1, negative 1. It's a function that passes through this point and has the same slope. It has a tangent slope to this differential equation and like goes with this differential equation at that point. Okay, And we'll get more into like visualizing these when we look at graphs later on this week. Alright, so just, that's like solving diffie-qs by separation. Okay, so next, we are going to have you practice. So I want you to try this problem on your own. It's a little tough, but like if you get stuck, keep powering through and then pause it, try it on your own, and then you will be able to see my work if you continue. So one thing I wanted to point out before you start is it says write the equation of the curve that passes through the point 3, 4 and has a slope of this, dy dx equals x squared plus 1. This does not look the same as the example problem we just did. This is actually the same wording, or it's like different wording to say the same thing as the first problem that we did. Find the particular solution to dy dx equals x squared plus 1 with the initial condition f of 3 equals 4. This means the same thing as this. We're finding the solution is the equation that passes through the point and has the same slope as the differential equation. That's what the solution is. Okay, so if you want, you can work off of this one. They're saying the same thing. Press pause. Try to use the steps. Separate, integrate, go through those steps, and then press play, and you will be able to see the solution. Okay. Alright, we're going to go through all these steps. I'm again going to try to color code for you. So y is going to be in blue. I'm going to write this down. We have dy over dx equals, this is our differential equation, and I'm just going to keep the 1 with the x squared plus 1. Okay. Sorry about that lighting. So, now, first step, separate. Remember, I told you the first thing you should always do, multiply dx times dx times dx. So then we get dy equals, and then x squared plus 1 dx. Okay, cool. This one's kind of weird because do we have another y? No, we do not. So, are we done separating? Are all the y's on one side and all the x's on the other? Yes, they are. So we're ready to do the next step. Next step was integrate. So we're going to integrate. Remember, when you're integrating this, if you don't see something in front of dy, you have a 1. So, we're integrating 1 with respect to y. That would be y equals the integral of x squared, x cubed over 3, plus the integral of 1 is x, and don't forget your plus c. Cool, so we finished step 2, which was integrate. Now we are going to go on to step 3, which is isolate y. Well, guess what? Y is already isolated. So yay, step 3 is finished. We got lucky on that one. Alright, step 4 was plug in your initial condition, or your point. Here's your point. Same thing as the initial condition. F of 3 equals 4. So we need to plug in 3 for x and 4 for y. So, 4 for y, 3 for x, cool, 4 equals 27 over 3, that's 9, plus 3 plus c, 9 plus 3, 12, we're going to subtract the 12, so we get negative 8 equals c. Alright, sweet, we are ready for our final step, which is to combine this and this, your c. Combine those things to write the particular solution. We're writing the particular solution. And remember, that always starts with y equals, and then we are going to just copy from our solution that had c in it, except instead of c, I'm going to put minus 8. So plus negative 8, that is the same as minus 8. That is the particular solution, so this would be your answer. I'm sorry, that looks like a square. Okay, cool. So, hopefully y'all got that practice. We're going to do another example that's kind of weird and involves a natural log. The AP exam loves to use this example with the natural log, so that's why we're going over it. Okay, so it says, suppose dy dx is proportional to y. Find the general solution to the differential equation that satisfies this condition. Alright, first things first, we don't have an equation. So we need to write a differential equation. That's one of the weird parts of this. So the first thing we're going to do is make this a differential equation. So let's translate. Is the same as what in math? That means equals. So dy dx, is means equals, okay, proportional. This means that it has like a multiplier, kind of, multiplier. I spelled multiplier wrong. There we go. So proportional means like you're going to put some multiplier. It's going to be a constant. Multiplier, that is a constant. So if it says something is proportional, you're going to have some constant multiplier. What I'm going to do is I'm going to make my constant k, because I don't want to confuse it with the c that comes from like integrating. So here's my k. Proportional to, this means multiply it by whatever it's proportional to. Proportional to y. So k times y. Okay, so now we actually do have a differential equation. And we're trying to find the general solution. Keyword being solution. We want to get what y equals. Anytime you're doing that, try to separate, integrate, do your steps. Okay, cool. So we are going to do our steps. I will color code it again for you. So y is in blue. dy over dx equals, and then we have, there we go. Okay, then we have k. I'm going to just leave the k like kind of on its own, and then y is in blue. Yeah. Okay, we're going to do the very first thing that we should always do when we're separating, which is multiply by dx. So we have times dx times dx. We got to get that out of the denominator. We have dy equals k, y dx. And now we need to get the y on the same side as the dy. So we're going to divide the y. So divide by y. We have dy over y equals k dx. Okay, really quick, remember, our next step is to integrate, and I told you I would really like for you to put this dy out in front anytime we have a fraction. So we're going to change that to 1 over y. That's the same as 1 over y dy equals k dx. Okay, so now we're going to integrate, and we need to integrate both sides, and we should recognize 1 over, that's a natural log, and when you integrate 1 over y, you have to put natural log, absolute value, don't forget your absolute value of y, equals, k is a constant, so the integral of a constant is that constant, k, times x, plus c. Alright, cool. We have done the first few steps. Our next step is to isolate y. So, before we can isolate y for this problem, we need to remember, how do you get something that's inside the natural log out of the natural log? So, let's do that. I'm just going to write a little like natural log, reminder over here, reminder. If you have the natural log of y equals x, the base of natural log is e. And then when I taught natural log, I use a thing called chubby hand. So we're going to actually convert this log to exponential. Some people like to think of it as take e and raise both sides to the e. And then some people like to think of it as converting it. So you're going to start with your base, e, and do the chubby hand, e to the x equals y. And it doesn't really look like a very good hand right now, but that's supposed to be a hand. Also, if you raise both sides to the e, the natural log cancels out on this side. That's where we get the y from, and then you have e to the x on the other side. Okay, so we're going to use this trick to isolate y down here. Put in your base, e, And we will get e to the kx plus c equals y. So I'm going to write that down here. E to the kx plus c equals, absolute value of y. Alright, let me write that over here really quick. So we have e to the kx plus c equals absolute value of y. Alright, first of all, when we get absolute values with differential equations, oftentimes they will cancel out. So this is why. What does e to the x look like? The graph e to the x looks like this. It's always positive. It cannot touch the x-axis. There's an asymptote there. So if this is always positive, do I need to say I need to make this side positive? No. No matter what, it's going to be positive. It cannot produce negative y values. So let's drop our absolute value. Drop your absolute value. So we have e to the kx plus c equals y. And then we're going to have to do some math magic here. Let's break this up. Remember when you're adding exponents, you were actually multiplying before? So let's break this into two parts. E to the kx times e to the c equals y. Let me show you why I did that. Right now, we have two constants, right? We have k and c. We know our next step is to find the constant. Well, the problem is I do not want two constants to find. I only want one constant to find at any given time. I can't have like constants in more than one place. So I broke this up. How did that help me? Well, e to the constant. E is 2.781, right? That raised to another number, another constant, that is one big constant. So like I'm going to like denote that this is a big constant, c. That's just a constant. So now we have c e to the kx equals y. Alright, cool. And then let's see, we did not have an initial condition. So anytime that you don't have an initial condition, you are actually finding the general solution as opposed to what we were finding before, the particular or specific solution. So in general, this is our solution. So let's go ahead and like say this is the general solution. You are allowed to have c in your general solution. In the particular solution, we would have found c. And we'll have an example in a second. Okay, cool. We're almost done, y'all. Here is our last example. It is an AP exam, a piece of an FRQ. This is like the level that we need to be at. So I want you to try on your own first. So if you're watching on YouTube, then pause it. Try this on your own. See how far you can get. You have considered the differential equation given, that's here, where x is not equal 0. Anytime it says something like that, you don't normally have to stress about it. Find the particular, this is supposed to say particular solution, y equals f of x to the differential equation with the initial condition f of 2 equals 0. Okay, so pause it, try on your own, go. Okay, cool. We're going to go over this and then we're done with today's lesson. So let's go over this very last problem. It's got a lot of steps. It's pretty hardy. Don't be stressed though. And then we'll go through the points and you can see how many points you would have gotten on the AP exam. Okay, I'm going to split up by color. Actually, I feel like I did that enough in the notes. So I'm just going to like go with one color now. Just to like make this a little quicker and make my life easier. So here we go. We have the differential equation. First thing, I'm going to write this, dy dx equals y minus 1 over x squared. Cool. First step, isolate. So I need to do times dx, or not isolate, yeah, I guess isolate, or separate, sorry, separate. Times dx, cancels out on this side. I'm left with dy equals y minus 1 over x squared. I like to leave the dx on the outside because I know I'm going to integrate. Next, I need to get the x's, or sorry, the y's on this side with this y. So right now it's in the numerator. Some of my students have struggled with this in the past. If you have something in the numerator on one side and everything's being multiplied, it's just going to move to the denominator on this side. So it's in the numerator. We want to get it out of the numerator, so we're doing the same as kind of like this, multiplying by y minus 1, 1 over y minus 1. That's going to cancel these y minus 1's out. So you see how it was in the numerator, it moved to the denominator because it was separated by multiplication here. So these cancel, doop, doop, and we are left with 1 over y minus 1 dy equals 1 over x squared, don't forget your x squared, 1 over x squared dx. Okay, cool. Next step, we've separated. Y is on one side, x is on the other. Next step is integrate. I will do that in a different color just to kind of keep those steps clear. So now we're integrating both sides. This is a natural log. Technically it's u sub, but if you think about this as u sub, think about, okay, what would derivative of u be? U would be the denominator, but the derivative is just 1, right? So we're not going to need to like change it at all. We're not going to need to multiply by anything because it's just 1. So we actually get natural log because it turns into 1 over u. Derivative or integral of 1 over u is natural log. Absolute value of whatever was in the denominator, y minus 1. If you are like stressed about what I just did there, try to do u sub on this. Define u as y minus 1. You'll get the same thing. Okay, so we have natural log of y minus 1 equals, this is x to the negative 2. So the integral of x to the negative 2 is x to the negative 1 over negative 1. Don't forget your plus c. Okay, now that we have integrated, we need to isolate our y. Again, we're going to need to use this natural log trick. So remember, this is an e. This is going to look really scary, but don't be scared. This is an e, and we go chubby hand e to the x to the actually, you know what? Let's make this look a little cleaner before we go for this. It's alright, I'll write natural log e, absolute value of y minus 1. You can put in the e if you want. Equals, this is negative 1 over x. That's what this turns into, plus c. Okay. Now we're ready to convert this to isolate y. So we have e to the negative 1 over x plus c equals e to this exponent equals y minus 1. I dropped the absolute value bars because e to an exponent is going to be positive. Okay. Now, let's go ahead and finish our isolating y. We have, I guess I can do it in, I'll do it in this color. So we have y equals, and I add 1 on both sides, right? Plus 1, plus 1. So I have e to the negative 1 over x plus c plus 1. Okay, anytime you have this e to the negative 1 situation, what I really want you to do is split it. You have to split it. Or sorry, not e to the negative 1. E to an exponent, and you have it like one of the exponents is c. We need to split it. So this is the same as y equals e to the negative 1 over x times e to the c plus 1. Remember, e to the c is just a constant. So I'm going to call that, I'll call that constant c. That's just a big constant c. So we have y equals, let me go down a little bit, y equals, this is c times e to the negative 1 over x plus 1. Alright, now we need to go to our next step, which is plug in your initial condition. So I'm not sure if we even noticed our initial condition, but we go back, oh look, it gave us initial condition, f of 2 equals 0, 2 comma 0 is the point that we're trying to find this solution at. And y'all, just so you know, initial condition is a key word, differential equation is a key word, like saying that you should probably be using these steps. Particular solution, that's supposed to say particular solution. That's a keyword saying, hey, I should be doing these steps to solve the differential equation. Okay, so again, we have this point 2, 0. Let me write it down here. We have the point 2, 0. So I'm going to plug that in. You don't have to write the point down again, but I did just so that we can see it down here. Okay, plug that in. Y is 0, so 0 equals, I guess I'll go with my purple again. 0 equals c e to the negative 1 over x. Oops, 1 over, oh my gosh, y. Okay, 1 over 2, remember x was 2, so like I'm going to cross out the x. I plugged in 2 there, plus 1. Alright, now we need to isolate c to figure out what is my value for my constant. So minus 1 on both sides, we get negative 1 equals c e to the negative 1/2. And then I need to divide by e to the negative 1/2, so I get negative 1 over e to the negative 1/2 equals c. Alright, once you've isolated c, you're good. This is c. Now the last step, combine the two parts. We have to combine what c is with what y equals. And that's our particular solution. So let's go ahead and do that. Y equals, c was negative 1 over e to the negative 1/2. And then we have times e to the negative 1 over x. Ooh, I don't know why I just wrote that fraction that way. I hate writing in this way, and I just did. I don't know why. Okay, plus 1. Cool, and then we're done. You just have to plug in your c. Alright, now let's look at how you get grades for this question from AP Graders, and then we are done. Here we go. I'm going to try to do this side by side. Cool. Okay, so the first point that you get is, y'all, really quick, before we look at this, don't look. Before we look at this, I want you to notice how many points you can get on a Diffie-Q problem. It's insane, y'all. Like, you can get sometimes 4, 5, 6 points just from one part on a Diffie-Q FRQ on the AP exam. So, like, these could be easy wins for us. So I really want you to take this practice seriously. I want you to take this mastery check seriously. Try to learn this stuff, because if they throw this on your test, I want you to get all 5 points that were associated with this one part. Alright, so here we go. This was just part B. There were 3 parts to this question, this FRQ. It was question 5 on the 2008 AP exam. Y'all, this is the one that I took. Yay! Okay, so it's question 5 on the 2008 AP exam, part B. This was worth 6 points. One part, worth 6 points. Okay, now let's go through our points. First point, did we separate the variables? So let's check. Separate variables, 1 over, you can show that in your integral piece. So you can see I have 1 over y minus 1 dy, and I have 1 over x squared dx. Yay, I did that right. Right? I'm going to go down a little bit. Okay, step 2. Did we correctly take the integrals, or the antiderivatives? Did we do the integrals right? Y'all, this is worth 2 points. It's like 1 for each side. So, like, could you take the integral of 1 over y minus 1? You get 1 point. So here, let me put, this is 1 point for separating. You get 1 point for correctly taking this integral. And then were you able to take the integral of x to the negative 2? Or 1 over x squared, same thing. 1 point for that integral. This here, they were like insanely generous right here. It says includes constant of integration. So like, that means did you include plus c? That's like insanely generous. A lot of the time they won't give you that. So don't expect that point. It might be out of 5. Alright, next step. Did you use the initial condition? Just using it. Like, aka, did you take this 2, 0 and plug it in to your x and your y? Once you like isolated y. Or even before you isolated y. If you want, up here, you can like plug your initial condition in if you would like. But I like to isolate y first because you have to do it no matter what. As you can see, the last point is for isolating y. So your last 2 points are 1 for using your initial condition, and then very final point, solving for y. Okay. As you can see, you can get a lot of points on the AP exam on these types of problems. So please practice. Again, I can't say it enough, like how much I think it will be worth practicing these problems. Not only that, this shows up in a lot of degrees in college. It's very important, especially for engineering. So having some differential equations under your belt is going to be worth it. Also, if you practice today, I think that you will find that this process, it's not that hard. Like, seriously, I mean, it gets a little tricky with the algebra part, but like the steps, think about the steps that we did today. The separate, integrate. You guys can do those steps. Y'all got that. You can do those steps. So please practice. Use your mastery check to practice. If you get stuck, it's okay. It's probably just because natural logs are a pain in the butt and we forgot how to do those, or because we forgot some like algebra things. So don't stress if you get stuck, but please try your best and then come to office hours if you do not understand any of this. Okay, I miss y'all. I will talk to you soon. I hope you enjoyed the lesson. Adios.